right, so first few examples here are just working with operations of polynomials. So you just really have to pay attention to what's in between the parentheses. So this one's subtracting. So typically when we do this, you can throw a little 1 in front of there. If it's subtraction, you do have to distribute. So this would be like minus x to the third, minus 2x, and then a negative times a negative would be a positive. And then leave the first one. And then it's combining like terms. So just remember, like terms are things with the same exponent. And biggest exponent always goes first. Keep the sign in front. So this is negative x to the third. And then you want to gather your x squared. So there's only one thing that has an x squared. Then there's the x's. So plus 4x minus 2x, that's plus 2x. And then 7 and 3, that would be plus 10. Okay, so just combine like terms. So number 2 is really the same thing. You don't really have to distribute a plus sign because it's all the same. So really you can just kind of look for your like terms right away. So biggest exponents here would be the 4s. So combine those. Negative 5 plus 17, that's 12 x to the 4th. And then your x to the thirds. So remember, if there's no number in front, that's a 1. So 3x to the third minus 1x to the third, that's 2x to the third. Minus 10x, that's the only thing with just an x, and then plus 1. So that's it. Those are just combined like terms. And then a question like number 3, that one's a little bit different. There's nothing in between, so it means multiply. So we want to take this 2x and multiply it to everything on the other side. So 2x times 3x to the third, that's going to give you 6x to the 4th. Multiplying, you do change the exponents. 2x times negative x squared, that's minus 2x to the third. And then 2x times x, that's plus 2x squared. So distribute the 2x to everything and then do the same with the 5. So 5 times 3x, that's 15x to the third. 5 times negative x squared, that's minus 5x squared. And then 5 times x, that's 5x. And then just like the other questions, combine like terms. So that's the only thing with a 4. I have a minus 2x to the third plus 15x to the third, so that's plus, not 12, that's plus 13x to the third. This would be minus 3x squared, and then plus 5x. So that's standard form, everything's in order, so that looks good. Okay, so that was the first thing, just operations, add, subtract, multiply. Second part was factoring. So we had a new method to factor things with 4 terms. We called that grouping. So we drew a line down the middle and find the GCF of each side. So what can you take out of both terms on each side? So on the left, they both have at least an x squared. That's like the biggest thing they have in common. And then on the right, you can divide both by 7. Okay, so take your GCF out, figure out what you have to multiply by. So x to the second times x would give you x to the third. X to the second times negative 5 would give you negative 5x squared. Okay, on the right, we take out a positive 7, so I just like writing that plus 7. 7x, and then we want minus 35, so minus 5. So remember, whatever's in the parentheses should always be the same. We get x minus 5, so that's one of our answers. And then the other answer is grouping together the outside parts. And that's it. Okay, so that's grouping. Another type we did was difference of squares. And this is really the same thing as if this were x squared minus 16. So you can go right to your factors. Square root of 16 is 4. One's plus, one's minus. But instead of just x and x, since we want x to the 4th, we just change these to say x squared. And then sometimes you're done. But this one, 4 is also a perfect square, so we can factor this more again because it's a minus sign. So this will become x plus 2, x minus 2. Okay, and then this one we can't change because it's a plus sign. So these would be our final factors. We're not solving it, so that's as far as we go. Okay, and then last one, number 6 here. This is 3 terms. Anything with 3 terms, we do it with the x. So we want to multiply to 21. Oops, not add to 7. Add to 10. So that would be 7 and 3. So then again, just like the last one, we don't want x, we want x squared. And then we're not solving, so that's it. Okay, next part of this unit was synthetic division. So a couple of reminders. Use the opposite of the factor. Remember, factor is anything in parentheses. Don't forget to look for missing terms and use a 0 in its place. So remember, synthetic division, we have this little box. Here's a factor, so we use the opposite of that number. And then we want to use all these coefficients. So 1, and then -2, and then 2, and then -5, and then draw our line. Always bring down the first number, and then we multiply. So 2 times 1 is 2, and then we add going down. So we get a 0 here, and then we multiply again. So this would be 0, add going down, multiply, add going down. And then remember, our answer is always going to start 1 degree less than whatever we started with. So x to the third, our answer is going to start with x to the second, and then you have your constant and then your remainder. So these division questions, we're not asking you to factor or anything. It's just write this part out. And if you have 0 x's, you can skip that. So this would just be +2. That's your constant. And then you have a remainder. So we just typically write plus, and then your remainder over x minus 2. And that's it. Okay. So number 8 is the same thing. So I want to divide, so I use my box, use the opposite of the factor. Just make sure if you skip any terms, you have to put a 0. So here I have 3x to the 4, -13x to the third. There's nothing in there that says x squared. So I do have to put a 0 in the next spot. And then I have my x, and then I have my constant. Okay. Now, I believe this one gives you some pretty big numbers, so I might have to grab my calculator. But we can multiply. So bring down the first number and then multiply. It's -28. And then, yes, I'm going to need my calculator. So -5 times -28 is 140. We're going to multiply again. And 140 times -5 is -700. Add down, that's -712. I know these are big. -712 times 5, I'm just doing this in my calculator, is 3,560, and then we're going to add those. So I get 3,546. Okay, I know those are big, but the idea is still the same. So since we started with x to the fourth, this one's going to start x to the third, and then we just go in descending order. So our answer here will be 3x to the third minus 28x squared plus 140x minus 712, it ran out of room, plus my remainder divided by whatever you were dividing by in the first place. Okay, so that's just straight up synthetic division. All right, couple reminders on finding zeros. Do not change the sign of the x value. That's talking about the number for the box. So if you're given a 0, you'll use synthetic division first to make the polynomial smaller. Then you'll take the remaining polynomial and factor to find the other zeros, or factors, depending on what's being asked. Okay, so number 9, given that 4 is a 0. So given that, that's the number that goes in the box. Don't make it the opposite. That's only if you are given a factor. All right, let's do synthetic division. Bring down the first number, multiply, add, multiply, add. Remember, you can always pause me and catch up if I'm going too fast. You should get a remainder of 0 for these. When you're given something to start with, you should get a remainder of 0. Then just like the last question, this will start x squared, x, constant, remainder. But we're not done. So this is x squared plus 2x minus 3. Now the question here is saying factor. So I'm going to factor this. I want what multiplies to negative 3 and adds to 2. So that'll be 3 and negative 1. So that's x plus 3, x minus 1. Now I need to decide, do I need to solve those or are those my answers? Since this says factor, those are factors. So I'm not going to solve them. But since this is x to the third, I am missing 1. And this is kind of the trickier one. 4 is the 0. So I'm not going to say x plus 4. I'm going to say x minus 4 because factors and zeros are opposites. Okay. Number 10 is the same idea here. So given negative 3 is a 0, put that in the box. Okay, do your synthetic division. Work through this. So remember, you should be getting a remainder of 0 for these, and we do. So this would be my x squared, my x, my constant, my remainder. So I bring that up. Now this one I want the zeros, so I do need to factor. So I'm going to multiply to 10, add to negative 11. So that's 2 negatives, negative 10, negative 1. So that's x minus 10, x minus 1. Now the last question, those are my answers. This one, I want the zeros. So I need to branch these out, set them equal to 0. So we're going to get positive 10 for one answer, positive 1 for the other. But remember, there's supposed to be 3. That's my degree. So just remember we gave you the other one. And since that is a 0, no need to make it opposite, but those are my answers. Okay. Kind of the last idea here is if I don't give you something to start with, so if no x value is given, then you use the calculator to graph, and you pick one of the x intercepts. Then follow the same steps as above. So I don't give you a number that you're supposed to put in the box. Okay, so this is where we're going to have to do some graphing. Let's see, where's my graphing calculator? There it is. All right, so you have your TIs. You can also use Desmos if you're at home. So we want to type this in. So x to the third minus x to the second plus 49x minus 49. All right, we got our graph. This one only has one nice x-intercept. On Desmos, you can just touch it. On your TIs, you're kind of just looking at the tick marks. It's 1, so don't change it. Just use that number. Okay, it's where it crosses the x-axis. So we're kind of done with the graph. Now we're going to do the same thing we did before. So I have 1, negative 1. Don't forget that negative 49, negative 49. Do synthetic division. Again, remember, if I go too fast, you have the power to pause me. Should get a remainder of 0, which we do. All right, now this one. Again, I'm going to start x squared, x, constant, remainder. When I go to write this one, that's bad. I have x squared. There is no x term, so I'm just going to skip that, plus 49. I want the zeros, so I'm going to set this equal to 0, and I need to solve it. I can't factor that one, so I'm just going to straight up solve it using square roots. So square root both sides. Remember, when you square root, you got plus or minus. This is negative 1, which is I. Square root of 49 is 7. So you get plus minus square root of 7. Sorry, not square root. Plus minus 7i. That's 2 answers. You're supposed to have 3, so don't forget the other one is the one we got from the graph. Okay, so that kind of just puts everything together. Last couple of questions on the back are just kind of how would you do this? How do you verify if a given value is 0? Every question we had where like I gave you something, the remainder was supposed to be 0. So that's all you're checking for. Use synthetic division. Check if the remainder is 0. So you're just showing work. And if you get 0, you put a check mark and it's good. Okay, last one. How many zeros will the following function have? Hint, check the degree. Remember, that is just the biggest exponent, the biggest power, biggest exponent. So on this one, it's just 5. There's 5 zeros. Just remember, zeros also mean solutions, also mean x-intercepts. All right, so hopefully you answered the questions that came up, and then let us know when you're ready for your retake. All right, thank you.